Assalamu alaikum everyone. Welcome to another video of Chemistry at Sarab Sambe. In this video, we're going to see the apparatus which are used in the laboratory for the measurement of time, temperature, masses and volumes. Let's first look at time. In laboratory, the most used apparatus to measure time is a stopwatch. This is a stopwatch. As you can see over here, it has a start button. So if you press this button, the stopwatch will start working. And if you want to stop the stopwatch, you have to press the same button again. The stopwatch will stop working. If you have to reset it and bring it back on zero, you have to press this button. And you have to change the mode, you have to press this button. Now, stopwatch, the time is basically recorded in the SI unit of seconds. The stopwatch records time to seconds. Currently, you can see that the time is recorded as 12.38 seconds. This is the actual time, 12.38 seconds, right? But usually in your experiments and your syllabus, they ask us to record the time to the nearest second. So time is recorded to the nearest second. So how do I make 1238 to the nearest second? I'll just round it off and I'll just write it as 12 seconds. The nearest second to 1238 seconds is 12 seconds. So I will record 12 seconds in my answer. If I want really accurate answers, the really accurate is 1238 seconds. And these are also seconds. So 28, 29, 30, 31, and then it's going to be 39 seconds and so on and so forth. That will be really accurate. But usually in your experimental questions in ATP, they ask you to record time to the nearest second. So I will just round it off and I'll write it as 1238. We also have stop clocks, but stop clocks are not very accurate. So we use stopwatches in particular when we are recording time. Keep in mind, stopwatch records time in seconds, not minutes, not hours, just seconds. Let's move on to temperature. For temperature, we have two types of thermometer. Here you can see mercury in glass thermometer. Mercury in glass thermometer. And here you can see alcohol in glass thermometer. Both of these thermometers can be used in the laboratory. However, mercury in glass thermometer, the disadvantage of that is that mercury in glass thermometer, if this glass breaks, then the mercury will leak out and it can cause mercury poisoning. The mercury would be on your hands and it can cause mercury poisoning. So to avoid that, we don't use mercury in glass thermometer. We can also use electronic thermometers. In electronic thermometers, you just put this is a probe. So you just put this probe inside the liquid and the temperature will be recorded on the screen like here. So you just put the probe inside the solution of which the temperature you need to find out and you can get the temperature. But usually for our experiments, they give us the thermometer. They give us mercury in glass thermometer or alcohol in glass thermometer. So we'll have to measure the temperature in degrees Celsius. So temperature is measured in degrees Celsius because this is a degree Celsius scale. You can see on the thermometer it's degree Celsius. So the thermometer has to be in degree Celsius. Okay. So the temperature is measured in degrees Celsius in our course, right? And if you see the least count of a thermometer, that is 1 degree Celsius. So you see 0. So if you see the graduations here, or you can see it on alcohol thermometer. This is 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the least count, the least volume, the least temperature that can be recorded is 1 degree Celsius, as I've just shown you. Let's move on to mass. For mass, you have electronic mass balances. So this is an electronic mass balance, you can see. Electronic mass balance. In this case, this is a 2 dp mass balance. It's a 2 decimal place mass balance. Because if you see, this is 0.00 right now, but then if I put a beaker containing, let's suppose, a particular solid inside it, so this might show 12.69. So it's a 2 dp mass balance. We can also have a 3 dp mass balance, and 3 dp mass balance will be more accurate than a 2 dp mass balance because it's just showing mass to 2 decimal places. Note, a 3 dp mass balance will be more accurate than a 2 dp mass balance. And for masses, we just use electronic mass balances. We don't use beam balances because it's not an accurate way of measuring masses. The beam balances are obsolete right now. In terms of volumes of liquid, the most important apparatus is a burette. And a burette accurately measures the volume, because if you see, this is how a burette looks like. So a burette can measure, is accurate to the least volume. The least volume a burette can measure, let's see, is, so you have 0, and this is 0.5, and this is 1. So the least volume a burette can measure is a 0.1. You can see over here. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So between 0 to 1, there are 10 graduations. So burette can measure, the least volume a burette can measure is 0.1 centimeters cube. Hence, volume of liquids are measured in centimeters cube. And masses are measured in grams here, using the electronic mass balance. And the burette can hold up to 50 cm cube or 50 ml. Keep in mind, 1 ml is 1 cm cube of a liquid. So a burette has a capacity starting from 0 to 50. You can see over here. Okay, now let's move on to the next apparatus, which is a volumetric pipette. Now a volumetric pipette measures fixed volumes. They don't have graduations, and you can see they will just have these marks. You see these marks? These marks tell you the maximum capacity. So this is a 5 ml or 5 cm cube volumetric pipette. This is a 10 ml or a 10 cm cube volumetric pipette. This is a 20 ml or 20 cm cube volumetric pipette. And this is a 25 ml or 25 cm cube volumetric pipette. This one is the most used in labs. And in titration. Then we have another apparatus to measure volumes, that are measuring cylinders. Now measuring cylinders measures approximate volumes. They're not very accurate. So they measure approximate volumes. Not accurate volume. So this is a 100 cm cube or a 100 ml measuring cylinder. This is a 50 ml or 50 cm cube measuring cylinder. This is a 10 ml or 10 cm cube measuring cylinder. You also have a 250 cm cube measuring cylinder, which is the largest. And you also have 1000. But we in chemistry, in our ATP, we're going to use 10, 50, 100 a lot, and 250 as well. Okay. The next apparatus is volumetric flask. Now volumetric flask also measures fixed volumes, like a volumetric pipette measures fixed volumes. So the two apparatus that measures fixed volumes are volumetric flasks and volumetric pipette. Fixed volumes. This is a 250 ml or a 250 cm3 volumetric flask. This is a 100 ml or 100 cm3 volumetric flask. This is a 25 ml or 25 cm3 volumetric flask. This is a 1000 ml or a 1000 cm3 volumetric flask. The 250 cm3 volumetric flask is the most used in labs. Used in labs for titration. This one is the most used. The 251. Then we can measure volume of gases using gas syringes. As you can see. Now this is a 100 ml gas syringe or 100 cm3 gas syringe. This is a plunger. This is the plunger. You plunge it out so that the gas can fill in. You plunge, you pull the plunger out so that the gas can fill inside the gas syringe. This is a 100 ml or 100 cm3 gas syringe, and we can have gas syringe of variable volumes as well. So these are the apparatus which can be used in the laboratory. Now you will also find in a lot of places you will see beakers. But beakers are usually used to contain approximate volumes of liquids or solutions, or beakers are just used to contain liquids or solutions. Beakers are not really used to measure the volumes of liquids because beakers are not accurate at all. So beakers are just there to contain or to just have the liquids or solutions inside them. So I hope this concept is clear to you. Thank you very much, everyone.